Guys, last little lecture from me, and I hope to see you all next year. Although I'm looking at the YouTube analytics, and I'm seeing that very few of you are watching this, and those of you who do watch it watch 33% of these things. So this is, I don't know how useful this is at all, but this is going back over the 10 multiple choice questions from last year's exam. So the repeat exam and the actual exam in May from last year. What I want to do is I always want to go through these and show you how easy it is. Everything follows from the basic idea that I squared is equal to -1, and that exponential I theta is cos theta plus I sine theta. So just basically two rules. Everything follows from those two rules. So question 16, we already did, I think, as part of our matrices kind of little roundup. This is question 16 from 2019. So this is last May's exam, and you had to get the determinant of 2 plus I, minus 2 plus I, and 4I. And so the way you get a determinant of a 2 by 2 matrix, even if the numbers are complex, is this by this minus this by this. So it's 4I into 2 plus I minus I into minus 2 plus I. Right, so that's the basic rule for getting determinants for a 2 by 2 matrix. So it's this by this minus this by this. And so when you multiply that out there, guys, you get 8I plus 4I squared. Minus by minus gives you plus 2I, and then minus I squared, I think. So that gives you 8 plus 2I gives you 10I. I squared is -1, so that's -4. And minus by minus gives you 1, that's +4, I think. So what you get then is -3 plus 10I. So that gives you the answer to question 16. So it's the basic idea of determinants and the fact that I squared is equal to -1. That's all this is testing. Come on, this is a joke. Yeah? So question 17 then was same basic idea, just testing. You had to get, here was a complex matrix, 2 plus I, minus 2 plus I, 1 plus I, and minus 1 plus I, and you had to get the inverse of that 2 by 2 matrix. Now, when you're getting the inverse of a 2 by 2 matrix, the very first thing you do is you get the determinant. Okay, so the first thing you do is you get the determinant of it and make sure it's not 0. Otherwise, because if the determinant is equal to 0, you can't get the inverse. Now, you can get the inverse of complex matrices. That's okay, provided, of course, the determinant is not equal to 0. So let's get the determinant here first. So it's the same as question 16. Basically, it's this by this. So it's 2 plus I by minus 1 plus I minus 1 plus I by minus 2 plus I. So it's a little bit involved, but not too bad. So when you multiply the first one out there, you get minus 2 plus 2I. So it's 2 by this, minus 2 plus 2I, minus I plus I squared. Minus, if I multiply these two out, then I get minus 2 plus I minus 2I plus I squared. And so when I do that, then guys, here I'm going to get 2I minus I, so I'm going to get I. And I squared is -1, and -1 minus 2 is -3. Minus into, when I multiply that out here, folks, I get minus I as the I term, because minus 2I plus I, and I squared is equal to -1, so I get -3. Now, you see here that minus gives you plus, so I get 2I, and I get -3 and +3, so I just get 2I. So the determinant here is 2I, and that's fine, it's not 0. So minus by minus gives you plus here, so that's the way the 3's will cancel. So the determinant is 2I. So therefore then, the inverse of this matrix is very straightforward. Then, once you've got the determinant, so the inverse then of 2 plus I minus 2 plus I, 1 plus I minus 1 plus I, the inverse of that then is 1 over 2I. into. You switch these two, so you get minus 1 plus I, and you get 2 plus I, and you change the sign here. So this becomes 2 minus I, and this becomes minus 1 minus I. And you can multiply in by the 1 over 2I. You can write 1 over 2I as I over 2 squared over 2I squared. So all I'm doing here now, guys, I'm taking this term here and I'm multiplying above and below by I, because we hate i's below the line. So what you do to get rid of an I below the line is you multiply above and below by I. So it's minus 1 plus I, 2 minus I, minus 1 minus I, 2 plus I. And that gives you I squared is a minus 1, so you get minus I over 2 into minus 1 plus I, 2 minus I, minus 1 minus I, and 2 plus I. And then you multiply in by the minus I minus 2. If you want to, I don't know what the answer, I don't have the answers, the paper in front of me, but you can multiply in here by, if you look at the first term, then all you get then here is, you must multiply each of these numbers here by minus I over 2. So you get minus 1 plus I by minus I over 2. And similarly for the other ones, and you multiply it out. So it's very straightforward. I won't go into the gory details. So you just multiply each term in the matrix by minus I over 2, being careful that I squared is equal to minus 1. So the first term here, look, if you multiply out here, you get minus minus plus, so you get I over 2. Yeah, and then you get minus I squared over 2, and I squared, so I think you get I over 2 over half. So it's a half plus I over 2 as the first term in your matrix, and similarly for all the other terms. Okay, so that's question 17 from last May's exam when we had real exams. Next thing you do then, folks, is we're going to be looking at sorry guys, I'm looking for a calculator, of course, because I haven't got one. But question 18 then is from last year's exam, the polar form of 1 plus 3i. Okay, so what you do is you draw your little diagram. 1 is here, 1, 2, 3. This is your line here. So this is the imaginary part of Z, and this is the real part of Z. So it's in the first quadrant. Get your little right angle triangle here. This distance here is 3. This distance here is 1. This distance here is 3. This is theta. This is the argument. So what you get here then is, and this is r. So you know that r squared is 3 squared plus 1 squared, which is 10. So therefore r is the square root of 10, because r must be positive. And that tan of alpha, or tan of theta, is 3 over 1, which is just 3. So then you get theta then is tan inverse of 3. You get that, make sure you're in radian mode. And then your polar form is very simply the square root of 10 exponential I theta, whatever theta is from that. That's all it is. Very important to be able to switch from Cartesian form into polar form. It's easy going the other way because you just use the Morgan's theorem. You just use the fact that exponential I theta is cos theta plus I sine theta. But going from the Cartesian form into polar form, you need to draw your diagram and then figure out what theta is from the diagram. You always know that r is the square root of the real part squared plus the imaginary part squared. But figuring out what the argument theta is sometimes can be a little bit tricky. Not too tricky, but a little bit tricky, as you can see here. And make sure when you're calculating the argument, you're in radian mode. That is so important, boys and girls. Okay, so that's question 18. Question 19 is calculate 1 plus I to the power 10. Now, we talked about this in one of the lectures. If you have a complex number and it's raised to a very large power, you could multiply 1 plus I by itself 10 times, but you would lose the will to live, and you're going to make a mistake. It's just too complicated. So what you do is you transform the Cartesian form into the polar form, and then use the laws of algebra. So here what I'm going to do is I'm going to look at 1 plus I first. And 1 plus I is 1 along here, 1 along here. Here's the real part of Z, and here's the imaginary part of Z. And this is theta. So R is the square root of, for 1 plus I now, folks, it's 1 squared plus 1 squared, which is the square root of 2. And theta is tan inverse, or no, yeah, it's tan inverse. Let me just not skip ahead. This distance here is 1, this distance here is 1, so therefore tan theta is equal to 1. So therefore theta is tan inverse of 1, which is pi over 4 radians. Okay? From your log tables. Because it's a very important angle. Okay, so it's 45 degrees, which is pi over 4 radians. So therefore, then, 1 plus I, this pen is running out, is the square root of 2, or can I write that as 2 to the power of a half? Why not? Exponential I, pi over 4 to the power of 10. And I can, because now I've got two multiplications here and I've got a power outside, I can write that as 2 and to the power of a half to the power of 10, exponential I pi over 4 to the power of 10. And 2 to the power of a half to the power of 10 is just 2 to the power of 5, which is 32. And that's exponential I 5 pi over 2. Okay. Now you can mess around with this. Remember, you can add and subtract. You can add and subtract 2 pi from every argument and still have the same argument. So 2 to the power of 5, folks, is 32. Exponential I. If I subtract 2 pi from 5 pi over 2, I just get pi over 2. So now I can rewrite this then as 32 into cos pi over 2 plus I sine pi over 2. And cos pi over 2 is 0, and sine pi over 2 is 1. So what I end up with, folks, is 32i. Now, that might be a little bit problematic for some of you, but it shouldn't be, because all I'm doing here is I'm subtracting. I want to, I know what cos pi over 2 is. Cos of 90 degrees is 0, and sine of pi over 2 is something that you should always remember. It's 1, or sine of 90 degrees is 1. So, and that's the reason why I subtracted 2 pi from this. You can add and subtract multiples of 2 pi from the argument and still have the same argument. So if I subtract 2 pi, which is 4 pi over 2 from this, I get exponential pi over 2. And then when I use de Moivre's theorem then here, I get cos of pi over 2 plus I sine pi over 2. Cos of pi over 2 is 0, sine of pi over 2 is 1, so I get 32i. So that's question 19. And the last one then was writing cos in terms of complex exponentials. We did this in lectures. We know that exponential I theta is cos theta plus I sine theta. And therefore exponential minus I theta is cos of minus theta plus I sine of minus theta, which is, if you look in your log tables, cos of a negative angle is the same as cos of the positive angle. And sine of minus theta is minus I sine theta. So now if you add these two things here, on the left-hand side, you get exponential I theta plus exponential minus I theta. And on the left-hand side, on the right-hand side, the signs will cancel because this is plus and this is minus, and you get 2 cos theta. So therefore, cos theta is equal to exponential I theta plus exponential minus I theta over 2. And I think in the exam, theta was represented, the angle was represented as omega t. Doesn't matter what you call it. So you get exponential I omega t plus exponential minus I omega t over 2. So that's the answer. All based on this result, the most important result in complex numbers. Well, no, that's not true. The most important result in complex numbers is that I squared is equal to minus 1. And from that then follows this result, that exponential I theta is cos theta plus I sine theta. That is so important. And you will see that as you go through your engineering education. So why not kind of get on top of it? All right, so that's question 20. Excuse me a second, I just want to make sure that this thing is still recording because I've had problems, as you know. Well, I have problems and I've had problems with this. All right, seems to be going well. All right, good. Now, what I want to do now, guys, is I want to look at the repeat exam from last year, from last August. Okay, so the question 16 from the repeat exam was, if Z1 and Z2 are complex numbers, what's the real part of Z1 and Z2 multiplied by Z2? Okay, so this is kind of a little mathsy kind of stuff, but it's, folks, Z1 is a complex number, Z2 is another complex number. So let's call Z1 X1 plus IY1. Why not? And Z2 is X2 plus IY2. So I'm multiplying, I want the real part of Z1 multiplied by Z2. So I need to multiply Z1 by Z2 in order to get that. So Z1 by Z2 is X1 plus IY1. That's X1 plus IY1, X2 plus IY2. Multiplying that out, I get X1, Y2 plus I, X1, Y2. No. I get X1, X2, right? X1, X2 plus I, X1, Y2 plus I, Y1, X2. And the last term here, you have to be careful. You get I by I, which is I squared, minus Y1, Y2. So you get X1, X2 minus Y1, Y2 plus I into X1, Y2 plus Y1, X2. That's the real part. So the real part of Z1, Z2, X1 is the real part of Z1, X2 is the real part of Z2, minus, this is the imaginary part of Z1, and this is the imaginary part of Z2. So the real part of Z1 multiplied by Z2 is that. Okay, so the real part is Z1, the real part of Z1 is X1, the real part of Z2 is X2, and Y1 is the imaginary part of Z1, and Y2 is the imaginary part of Z2. So that's what you get. And that's not one of the answers that's given. So the answer is none of the above. Okay? So that's a little bit of mathsy, so just messing around with just kind of symbols, which I love. Nobody else does. Nobody cares anymore. This used to be important maybe about 100 years ago, but maybe it's not important now because everyone has software and Google. So important. All right. Question 17 was kind of like one of the questions in the summer paper. I asked you for 1 plus I to the power 4. And if you remember back, I asked you for what, I showed you what 1 plus I was in terms of its polar form. 1 plus I is root 2 exponential I pi over 4 from question 19. Okay, now you could conceivably, if you wanted to, you could just multiply that out. That's 1 plus I by itself, you know, in Cartesian form. You could do that, multiply 1 plus I by itself 4 times. But it's probably easier to write in polar form. So you get 2 to the power of a half exponential I pi over 4 all to the power of 4. You bring the power into each of these two things here. So you get 2 to the power of a half by 4 by multiplied by exponential I pi over 4 by 4. And the 4 so we cancel. So what you get here, and that's just, if I come up here, 2, that's 4 over 2 here. So you get 2 squared exponential I pi, which is 4. 2 squared is 4 into cos pi plus I is sine of pi. Sine of pi is 0, as we all know. Cos pi is minus 1, so you just get minus 4. So it's pretty okay, I think. So this is just based on the idea that if you have a power outside a Cartesian form of a complex number, it's usually much easier to write the Cartesian form in terms of the polar form and then use the laws of algebra and the laws that the exponential obey, and you get the right answer. It's pretty straightforward, I think. But you could conceivably, in this case, multiply that out. 1 plus I by itself 4 times is not too bad. Whereas the exam question in the summer was 1 plus I to the power of 10. That you can't do that because no one can do that because it's just too complicated. It's just too long-winded. All right. So that's question 17 from the repeat exam. Here's question 18. Question 18 was fairly straightforward, actually. It's determined, though, with this I01, I minus 1, and 0, I0. So it's the determinant, it's a 3 by 3 determinant involving complex numbers. It's the same old nonsense, folks, as look. So it's I times, what do? You cover up this one and this one, you're left with a 2 by 2 matrix. So it's this by this, which is 0, minus this by this. So I think you get 0 minus 1 by I gives you minus I. Minus 0 by whatever it is, we don't care because it's a 0, so this is going to drop out. So the second term drops out because the second term here is 0. Plus 1 times, cover up that row, cover up that column, you're left with I by I, which is I squared, minus this by this, which is 0. So you're just left with I squared. So if you look up here, guys, minus by minus gives you plus. So you've got I squared plus I squared. I squared is minus 1, so I think you get minus 2. Very straightforward, I think. Question 19, bit mathsy, but not too bad. Look, I'm asking for z plus 3 by z bar plus 3, where z bar is the complex conjugate. Now, you don't know what z is. Now, you could write it as a Cartesian form or a polar form. You have a choice. In this case, because you're adding numbers to a complex number, you should use the Cartesian form. Okay, so when you're adding things together, you should use the Cartesian form. So let z equal to x plus iy. Just, we don't know what z is, so let x be I plus iy. So in the first term, then you get x plus 3 plus iy, and z bar then is x plus 3 minus iy. Okay? Then you multiply that out, guys, you get x plus 3 to be squared, this x plus 3 by x plus 3, plus x plus 3 by minus iy, plus iy by x plus 3, and you get cancellation. And the last one then is minus I squared, because it's I by I squared, y squared.